Okay, cyclist and bicycle combined mass 70 kilograms. Sends a straight hill AB, so the hill, constant slope. So it goes there from A to B and gets to B at 4 meters per second, and it was 0 meters per second at the beginning. Level of B is 6 meters above A, so that's 6 meters. Fine, first parts. So cyclist going on there, 70 kilograms. Increase in kinetic energy. So increase in kinetic energy is final kinetic energy. So half mv squared minus half mu squared. So that is a half times mass is 70 times by final speed is 4 squared minus a half times 70 times 0 squared, which is this bit here, and that is 560 kinetic energy joules. Part 2, increase in potential energy or gravitational potential energy. That's just mgh. So that'll be 70 times by g, which is 9.8, times by the height, it's gone up 6. So that is 4,106 joules. And then for part 3, during the ascent, resistance to motion is constant, so I'll put it in green, as I always put my forces in green. That's 60 newtons going backwards. Okay, maybe other forces need to go on there, but I've got the work done by the cyclist, so I've got work done, and work done equals increase in energy. And here we're going to have both the kinetic energy and the potential energy. But also, it's got that work done by the cyclist has got to counteract the resistance. So I'm going to have plus the work done against resistance. And so what is this? It's work done by a cyclist. So he gets work done by a cyclist. It says it's 8,000 equals increase in energy. Well, that'll be the kinetic energy, which is 560, plus this bit here, 4116, and then plus the work done by against the resistance. And so the work done against resistance equals 8,000 minus 560 minus 4116, and that equals 3324 joules. But that's the work done against resistance. I want to work out the distance AB, so I want to work out all the way from A all the way up to B. We'll call it X, and I know that the work done equals the resultant force, or the force, times by the distance. And the distance here we've got is X, so I'm going to have S equals the work done over the force. My distance is X, so X equals the work done. Well, I just worked it out. It's 3324, and divide it by the force, which is 60. It said here the force was 60, and that is 55.4, and it's in meters as a distance. And that's question 5 done.